Hello, in this video we will talk about statistical modeling and how does that fit in the whole concept of business analytics. So, business analytics, as you know, is a broad term or an umbrella term, and we can categorize it into three different types of analytics. Descriptive analytics, which deals with knowing what is happening in a business and understanding the underlying trends and causes. Some of the techniques we use for descriptive analytics include visual analytics, reports, cubes, etc. When you're dealing with predictive analytics, then we are trying to determine what is going to happen in the future. One popular technique for predictive analytics is data mining. Prescriptive analytics helps us recognize what is going on and it assists in making the best decision possible. So if you look at this chart, most companies that apply analytics often follow the trajectory similar to this chart. So we have on the vertical axis the competitive advantage received, and on the horizontal axis we have the degree of complexity. So most companies or most organizations will start here at the bottom left, and they'll start with some standard reporting and descriptive analytics or descriptive statistics and data visualization are both techniques for descriptive analytics, and they offer relatively lower competitive advantage compared to the predictive or prescriptive analytics techniques. So the companies would start somewhere here with descriptive analytics techniques, and as they see the advantages of these techniques, they often progress to more sophisticated techniques such as predictive analytics and so on. So statistics is a collection of mathematical techniques to characterize and interpret the data. Usually, statistical methods and underlying techniques are considered part of descriptive analytics. You can have the statistics classified as descriptive statistics, which helps us describe what the data is as it is, and we can have inferential statistics, which helps us draw inferences about the population based on sample data. I know I just introduced two new terms, population and samples. So I'm going to introduce some terms. First of all, data. We already know the facts and figures collected, analyzed, and summarized for presentation. Variable are the characteristic or quantity of interest. Observation is a set of values corresponding to a set of variables. What variation means is that this is the difference in a variable measured over different observations. So let me take this a little bit further and show you an example. So if we have this Excel worksheet, looking at the definitions, this whole sheet or this data that you see here is what I'm talking about when I say the data. Now, in each one of these, you will see some variables. So year is a variable, RK is a variable, team is a variable, overall GMS is a variable. So we have year variable, all of these are variables. So we have 6 variables here. Then let's talk about observation. What is observation? So one set of variables and data about them. For example, one row here, we have 2015, and I start with what, so it has data for year, data for RK, team, and so on. So one row here is an observation. The second row is the next observation. If I talk about variation, what I mean is, let's say we have one variable, variable D. So it has multiple data points as you see. So the variation of this column D or overall GMS, this variable would be what's the minimum value, what's the maximum value, how does it vary across these different observations. So based on whatever I can see on my screen, the minimum is 160, the maximum is 162. So there are multiple ways for us to determine the variation of data. The simplest way is to calculate a range, meaning maximum minus minimum. So if I do that for overall GMS or overall games, I get 162 minus 160 equals 2. That is the range of this data set. And that's one of the indicators of variation of one variable. There are others as well, like standard deviation or variance. We'll discuss those as well. Population includes all elements of interest for the statistical analysis. If we take a subset of the population, that constitutes our sample. Let me explain that with an example. So let's say I want to know what's the average rent paid by App State students. So if I were to ask that question to every single student who is registered on App State, that will be population. It's not possible usually. I can't go to every student and ask that question. Maybe I will ask 100, 200, 300 App State students. And then whatever they say, I will conclude that the same applies to the population. But to be able to do that, I need to make sure that I'm doing a good sampling or taking a good subset. I cannot take only College of Business majors. I cannot take only CIS majors. I cannot take all seniors. So it has to be a representative. The sample has to be a representative sample of the population. So I need to do random sampling. It means maybe I'll just stand outside PSU, and anybody who goes in, who is a student, then I can get their opinion. So this is random sampling. We previously discussed that data can be quantitative or categorical. Categorical data can be nominal or ordinal. Quantitative data can be ratio or interval. Now, another classification for data can be cross-sectional data versus time series data. So cross-sectional data is data collected from several entities at the same or approximately same point in time. Going back to my previous example, if I were to ask 300 app students about what is the rent they are paying, if I do it just once and then never do it again, then this would be a cross-sectional data. So I have asked 300 students, meaning 300 different entities, and at one point in time, that is today. On the other hand, what I could do is time series data, which is data collected over several time periods. So taking the same example further, if I ask that question about what is a typical rent for app students, and then I do it to the same 300 people over time. So maybe every 6 months, I'm going to send a survey to the same people over time and say every 6 months, what's the rent they are paying? That would be a time series data. Time series data are usually very helpful to understand what happened in the past and identify trends over time, and they can be used for forecasting.